Lesson 82, page 337 for your reference. Page 337, lesson 82. I wrote that totally backwards than what I just said. So way back, way back in lesson 28, we talked about the concept of a function and to the use of functional notation. For example, we've learned that this information here, that we're talking about the function of x. That there's one value for x. That whatever I replace this with, I can get a solution. So if I replace this with -1, then my problem looks like this. Correct? And I can solve it. All right, so let's move on. So let's take that information that we've already learned and let's expand it a little bit. So write this down in your notebooks. Find the function of x when x squared plus x minus 10. And the function is 5. So x is 5. So replace x with 5 everywhere. And my new problem looks like this. When I replace 5 everywhere, that's what I end up with. And then I could also solve that function of x when x equals 5 to tell me that the answer is anyone? What is it? 20. The answer is 20. So some older stuff we've kind of already done. Let's make it harder though. Function of x, x squared plus x plus 1 when we replace x with a squared. Okay, when I replaced x with a squared, that's what I end up with, which gives me a to the 4th plus a squared plus 1. And all I did was replace some information. Let's try one more old style stuff. X squared plus 1 when the function is x plus 2. So if I replace it with replace x with x plus 2, I get x plus 2 squared plus 1. So the function of x plus 2 equals x squared plus 4x plus 5. And the reason being is x plus 2 times x plus 2 is x squared plus 2x plus 2x plus 4. And I have to add the 1 into that. That's how I arrived at what I got. Make sure I'm not going too fast. All right, so now we're going to move on to domain and range. Let's switch gears now. We're still talking about functions. All right, so we're talking about definition of a function. So write down this definition for function. Function is a map from one set called the domain. The domain, I'm going to out of room on that, so I'm going to go down here. one set called the domain to another set, which happens to be called the range. Therefore, we get domain and range. Okay, and the comparison is 1 to 1. Each domain to one range is precise. And each element of the range corresponds to at least one member of the domain. And as you see when we do these, there is a definite relationship in these. All right, so let's give it a shot. All right, and I am going to switch over to a graph. If I can do this. Right, there we go. I'm going to switch over to a graph to help us illustrate that. All right, so if my domain in range is this, here's my function. Oh, that's not going to be, let's fix that. There we go. So if my function is this, let's find the domain and range of that function. We're going to find the domain and range of that function. Okay, we see that from that function that I put up there can be applied to any real value of x. So first off, my domain is all the real numbers. Well, that's pretty easy. The domain of f equals set of, I'm running out of room, real numbers. It's a set of real numbers. If I were to graph that function, starting at 0, because there's no y equals mx plus b, up 2 over 1, up 2 over 1, and then vice versa, down 2 over 1. If my domain is a set of real numbers, in this case with this function, my range is also the set of real numbers. My range for f is the set of real numbers because my x and y values can be any real number. It gets a little more complicated than that. So let's clear this up. It does get a little more complicated than that. So what if my function was now this? There's no x, just 3. And we have to find the domain and range. So what that means is I can apply any real number. So my domain of f equals, again, set of real numbers. But my range is different. My range could only be one thing. And that one thing is 3. My range can only be 3 because that's what's specified. So my range of f equals 3. Because that's the only thing it ever attains. It's the only answer I ever get is 3. So whether x is 1,000,000, 7,000,000, or 0, the function only equals 3. That's what I'm told. All right. So now let's move on to the graph part of it. So I'm going to draw a graph on the board, and we are going to create the function and all that other stuff, or the domain and range. So here's my graph. Open circle here. Line going to here. And then at 4, 3. Closed circle here with an F. Okay, there's my graph. The open circle is at -2, 3, correct? Okay, it's open circle, so that means it's not on the graph for the function. Okay, open circle, here's my graph of my function right here. Let's see if I can put the pen there, right there. This is not on it. Open circle indicates that. The domain of f is a set of numbers for which f makes sense, or as f is defined. We use the shorthand for that is the domain of f. So write this down. The domain of f. We're out of time on this one. Domain of f is, here we go, set this up. We got the set of real numbers with a line down after the set of real numbers, which means such that, remember E is the element that we're looking, E is the element of, that R is the shorthand for set of real numbers. And then we set up what it is. -2 is less than x, but x is less than or greater than 3. Or less than or that's a greater. That makes no sense. Less than or equal to 3. Because x can't be -2, can it? If you look this way, on your line, x cannot be -2, can it? And x can't go past 3. So your domain is within these two boundaries. Okay? Got that so far? Your range then, okay, y element real numbers such that, what's the smallest y can be? Look at the graph. What's the smallest y can be? As far down y goes down to 0, doesn't it?
Oh, yeah.
0 is less than or equal, because y could be 0, less than or equal to y, and y is less than or equal to as big as it can be, which is, how tall does it get? 4. All right, I need to stop the video here because I'm out of time. It's going to stop itself anyway.